On this channel, we provide useful programming information with practical code examples. This time, we will focus on the latest features of Python. We will explain the notable features of the Python 3.12 to 3.13 generations step by step from a practical standpoint of immediately usable applications. Enabling subtitles will make the code descriptions easier to understand. In recent years, Python has evolved with an emphasis not only on ease of writing, but also on robustness, speed, and readability. Below, we introduce the notable features from Python 3.12 to 3.13 generations. In Python 3.12, errors are now displayed in a more concrete and visual manner. You can instantly identify where mistakes are made and significantly reduce debugging time. Missing arguments are shown with the relevant line and location, so you won't get confused when identifying the cause. The match statement allows you to describe complex condition branches and data structure discrimination declaratively. Handling dictionaries and nested structures becomes especially more readable. Because you can perform condition branching and data extraction simultaneously, nesting if statements becomes unnecessary. The match statement is also effective for structured data such as JSON or API responses. You can extract only the necessary elements safely, reducing the need for defensive code. With f-strings, you can now add equals to display both the expression itself and its evaluation result at the same time. This feature is specialized for debugging and is extremely useful when you want to quickly check the contents of a variable. Because variable names and values are displayed together, temporary debugging with print statements becomes easier to read. You can write log outputs and verification code more concisely and in a more expressive way. In Python 3.12, a dedicated syntax for defining type aliases, the type statement, was introduced. This allows type hints to function not merely as supplementary information but also as a language element to clearly express design intent. By giving meaning to user ID or username, the differences in roles can be clarified even if both use the same int or str type. Type definitions become more concise, reducing the cost of understanding during code review and maintenance. Previously, type aliases such as user ID equals int were created by assignment, but using the type statement makes it explicit that this is a type definition. This is especially effective for improving design readability in medium-sized and larger code bases. Since Python 3.9, you can use built-in types like list or dict directly as generics. This allows you to write intuitive and readable type hints without importing types from the typing module. type hints function not as constraints, but as documentation that explains processing contents. Since Python 3.11, you can specify self as the return type for methods that return the class itself. This allows you to safely write method chaining code without losing type information. Even for methods returning self, the correct return type is preserved. IDEs and type checkers can accurately understand method chaining. From Python 3.9, specialized methods, str, removeprefix, and str, removesuffix, have been added to safely remove prefixes and suffixes from strings. With these, you can accurately express the intent of removing only the beginning or end in your code. The specified string is removed only if it exists at the beginning or the end, preventing unintended replacements. This approach provides better readability and safety than using replace or slicing. Especially for handling strings with a defined format, such as file names or URL preprocessing, using these methods can greatly reduce the risk of bugs. str.casefold in Python is a method for case-insensitive comparison that considers Unicode. Unlike simple, lower, or upper, it normalizes strings, including language-specific character conversion. It can properly handle language-dependent differences such as German, SS, and SS. This is an essential technique for applications based on multilingual support or internationalization. From Python 3.11 onward, the tomllib module for reading TOML configuration files has been added to the standard library. Configuration management can now be completed solely in Python, without depending on external libraries. External packages like toml are no longer needed, simplifying your dependencies. Configuration file loading is standardized, making distribution, operation, and C environments easier to handle. Python 3.11 introduced ExceptionGroup to handle multiple exceptions together and the except asterisk syntax to handle them safely in branches. This is a new feature to handle simultaneous errors appearing in asynchronous or parallel processing. Multiple exceptions can now be raised and classified in a single operation. It addresses the problem in asynchronous processing where only the first error could be seen. In operations like asyncio, gather, or parallel batch processing, multiple failure factors can occur simultaneously. Using ExceptionGroup makes it easier to organize error collection, logging, and retry strategies. From Python 3.11 onward, many processes have been made faster through internal optimizations. A major advantage is that speed improvements can be achieved without rewriting your code. In Python, using the standard GC module lets you temporarily disable or manually execute garbage collection. This is an effective optimization technique in scenarios such as batch processing of large datasets or performance-critical operations. Suppressing unnecessary garbage collection triggers can reduce fluctuations in processing time. You can explicitly collect at process intervals, making memory usage easier to track. However, this technique should not be used as a default optimization but only considered if profiling shows GC as a bottleneck. For most applications, it is safest to rely on Python's automatic garbage collection. With improvements in error messages and the evolution of type hints in the Python 3.12 to 3.13 generation, understanding and maintaining code has become easier than ever before. Additionally, enhancements such as better debugging experiences and performance improvements through internal optimization are steadily making direct contributions to productivity and practice. You don't need to use all these new features at once. It's practical to start with the latest Python version and gradually incorporate features as needed. This gradual adoption leads to more readable and robust Python code. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. I hope this video helps improve your programming life. By subscribing to the channel, we can deliver more useful information to you.